Okay, so in this chapter, we're going to be going over Lewis structures. Okay, and so we've already done Lewis dot diagrams. Remember, Lewis dot diagrams are going to be referring to our valence electrons, and we're going to obtain that information from the periodic table. We're going to look at the periodic table, use our group numbers for valence electrons. So for example, I kind of have them written down here, and you might want to do the same to your own periodic table to kind of help you today. But group 1 has 1 valence electron. Group 2 has 2. 13 has 3. So if you notice, when we get over here to the 13 through 18, we're just taking away that first one right there, okay? Or if you have one of these periodic tables, you're using the ones that have the A's next to them. Ignore the transition metals for now. All right, so 3, and then 14 has 4, 15 has 5, 16 has 6, 17 has 7, and 18 has 8. So we're going to be using that right now to kind of get some of these things drawn in. So I'm going to make that a little bit lower. All right, so carbon. Carbon was in group 14 right here. So we're going to draw 4 valence electrons. 1, 2, 3, 4. If you notice, I went around in a circle instead of doubling them up. Don't forget that that was something that you do need to do. And what that's going to help you do is find the spots where it's going to be able to bond. Anytime that there's only 1 electron, we're going to see that that's where it bonds. All right, something like sodium, okay, which usually we find in our ionic compounds. So you're not going to be using this much today for sure. But sodium is in group 1, so it's good to practice. So we have 1 valence electron that is showing right there. All right. Aluminum is over here in group 13, has 3. So we're going to go aluminum. We're using our chemical symbol in the center. We're going to go 1, 2, 3. And that's it. And we're going to see that it can bond on all 3 of those sides. Bromine is over here in group 17. So being right there, it's going to have 7. So we're going to have Br in the center and go 1, 2, 3, 4, 5, 6, 7. And that's it for the Lewis dot diagram. So this is what we've already done. Okay, so let me kind of minimize this real quick. All right, so for Lewis structures, when we're doing our electron dot notation for a covalent compound, now we're actually combining everything. So we have atomic symbols are the things that were in the center, right? We just saw that. We saw that on this one. Okay, so we put our atomic symbol in the center. Then we're going to show that we're going to have dot pairs or dashes between 2 atomic symbols. So we have not seen this. If you notice, none of these things are bonded yet, right? So all of these things are just dots going around 1 element. So what we're going to see now is we're going to actually end up pairing these up by showing a line, a dash in between 2 elements. We're going to find those lone or those single electrons, and we're going to bond them up, okay? The last part of it is that you do have dots that are only attached to 1 atomic symbol. Those are called lone pairs. And that is something that you do want to make note of as being an important vocab word. Okay. So again, we're going to have our symbol. We're going to have our our dash line to represent our bond. And we're going to have lone pairs. So you can kind of see in this image right here, and you'll want this during your little quiz today, but you have your shared electron pair. So that's your bond right there. And we're showing that with a line. So what this was he had 1, this one had 1, we bonded them together. We kind of connect the dots there. All right, here we have our lone pairs. So you see that they are existing as a pair. And we've kind of moved them to opposite sides of this chlorine to kind of spread them out. Key to bonding things, you want to spread everything out. And then you have your elements that we're representing with our chemical symbols. All right, next we have different types of covalent bonds. So we have 3 different types, and they're pretty simple to learn. So we have single bond, which is only 1 line. And what that is representing is that we had 1 dot for a chlorine, 1 dot for a hydrogen, we bonded them up. The other option that we have is we have a double bond. So as you can see here, we had a single electron here, a single electron here, 1 here, 1 here, and now these guys are bonding up to make a double bond. Please note the location of these oxygens. I just said oxygens, I meant pairs of electrons. I don't know why I was looking at the oxygen, sorry about that. All right, and then you have your nitrogens, the diatomic nitrogen. And so what you can see is this is a triple bond because nitrogen in group 15 has 3 single electrons. And so once again, we're bonding all of those up. We just make it pretty, and then we put those lone pairs on the outside to as far away from the bonds as possible. And you're going to see that that's going to help you with your structures. All right. So one of the really challenging things that we always see you guys struggle with is determining who goes in the center. So keep it simple, all right? First, try to do, actually, I would say the first thing that you should check for is if there's a carbon, that one goes in the center. That's your top priority. Next priority, never, ever, 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 ever put hydrogen in the center. Okay? Now, if you don't have carbon, you don't have hydrogens, you don't have any idea, then you go to these next rules where you have the unique atom is going to go in the center, meaning that there's only one of those. So as you can see down here in the example, for something like NH3, there's one nitrogen, there's 3 hydrogens. So nitrogen is going to go in the center, okay? And then your last thing that you could use is you could look at your periodic table and remember that your least electronegative, okay, so your most electronegative, just to kind of remind you, is over in this corner. I'm putting the heart because they love their electrons. So anything further away from that is also a good guarantee that it should go in the center, which is why carbon sits right here. It's usually the least electronegative from all of these things. Okay, so the last thing that's really important that I need you guys to also know, and you probably want to write these down, is you want to remember that everything needs 8, right? So our octets, I'm going to call them octet, which really means 8, but what I mean by that is we're going to say a full shell, okay? And we're going to be double checking that each atom is actually satisfying their full shell need, okay? And so everything, for the most part, needs to have 8 electrons around it. And remember, each bond represents 2. So don't forget, if once you have a bond, that counts for 2 electrons, right? Okay, other than that, you have lone pairs. So those are going to be 2 as well. All right, so the exception to this 8 is that hydrogen needs only 2. So it bonds and then it's done. Okay, the other weirdos that we've got is beryllium only needs 4, boron and aluminum only need 6. So you can write those down. We'll probably be using aluminum and boron every once in a while. We don't really give you guys too many berylliums, but just in case you have these numbers, okay? And you'll see it once you draw their valence electrons that you're like, oh, well, it can only bond twice. That's it, okay? So just be aware of these exceptions, but for sure, you need to write down hydrogen, and you need to write down that 8 is the normal number, okay? All right. Now, let's look at a couple examples of what we're seeing when we're bonding these. So we have nitrogen, who came from group 15, right? So we got that information from our periodic table, group 15, meaning it only has 5. Then we had hydrogen, which is in group 1, and it only has 1. So what I'm showing here is that we have our Lewis dot diagrams right here, right? So we're just preparing ourselves. But we know that we're going to need 3 hydrogens. Okay, don't forget, these little subscripts go to the guy right in front. Okay, and if there's no subscripts, that means only 1. So we have 3 hydrogens, 1 nitrogen. So we're going to throw nitrogen in the center because it's the most unique. We're going to draw those little hydrogens matching up to each of these single electrons on nitrogen. And then we're going to see that they bond, 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 and that's it. And just to do our double check at the end, you should always do this. We're going to see, okay, hydrogen has 2, done. Hydrogen has 2, done. Hydrogen has 2, done. And then nitrogen has 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so always do that check at the very end. All right, so let's look at a couple examples drawing. So we're going to start with carbon tetrabromide. Don't forget how to name those little covalent compounds. So we have carbon tetrabromide. So we're drawing these molecules. So don't forget, we got to look at the periodic table, get our valence electrons. So carbon, being in group 14, has 4 valence electrons. Bromine in group 17 has 7. So again, I'm getting this information from my periodic table. Carbon's right here, has 4. Bromine has 7. Okay. Then we got to determine who goes in the center. So for these, we have a carbon, yay! And it's also the most unique, right? So carbon for sure is going to go in the center. So we have that. So we're going to draw in our 4 valence electrons on there. And then we're going to draw in our bromines. And if you notice, I'm going to position them at each single electron on carbon. That's how you're going to kind of match these up, okay? Because each of those little single electrons that you're seeing on carbon have to get bonded up. So that's why I put those there. All right, then we're going to start drawing in our dots. So 1, 2, remember each bromine is going to have 7, okay? So what I'd like to point out is that I have 7 valence electrons that were there, and then this got bonded, so now bromine has 8 total. And that's what we're trying to do for each of these, okay? So remember, the single electron, we want it to be positioned so that it can bond up with carbon, with the other single electron, and then all together is going to be satisfying that octet or having 8. Okay, so we're just going to do that for each of these bromines. Just like that, okay? And so now let's go around and let's double check each of these. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Here we're going to go 1, 2, 3, 4, 5, 6, 7, 8. And then finally 1, 2, 3, 4, 5, 6, 7, 8. Okay, all right. Then we double check carbon. Carbon sitting in the center has 1, 2, 3, 4, 5, 6, 7, 8. Don't forget those bonds or those shared electrons each count for 2. Okay, all right. So let's look at our next example. We have oxygen. So I know that this was already in the slideshow, so let's just run through it really quick. Okay, remember oxygens each need 6. So we're going to draw in our oxygens. There's nothing unique, so we're just going to put them right next to each other. Okay, I went ahead and drew my 6 for each of them. And now you're going to be connecting those dots. Okay, and so now that we've connected those dots, let's make it a little bit prettier. So we're going to draw them a little bit more next to each other. So you can kind of see, since we already know that these are going to be the single electrons have to get connected, we're going to draw them next to each other like that. And then I'm going to take it one more step further, and I'm just going to draw them a little bit prettier. And I'm going to show that I see that we have a double bond, just like we saw earlier. So once you notice that you have two of the same atoms, or 2 atoms that are connected twice, that's what I should say, 2 atoms that are connected twice, that means it's a double bond. So make it look like a double bond. And you're going to put that right there in the center. And then we're going to draw our lone pairs around that. Okay, so one thing I want to point out here is make them look like pairs and then put them on opposite sides or as spread out as possible in the pair. So the pair should be further from this pair so that you can actually see that they have different locations. Okay, all right. Our last example, oh, sorry, not last example, but we're going to do phosphorus trichloride. Make sure you're still practicing those names. All right, phosphorus is in group 15 right here. So we're going to draw 5 valence electrons on phosphorus. And chlorine was in group 17, so he's going to have 7. So we're going to pick the most unique one because neither of those are carbon, none of them are hydrogens. We're going to put the one who is unlike the others, right? So phosphorus is going to go in the center. We're going to draw 1, 2, 3, 4, 5. Each of those chlorines are going to have 7. We're going to position them around this so that each of these single electrons are the ones that need to get bonded. Each of those single electrons are going to get connected to our chlorine, okay? So we have chlorine right here, 1, 2, 3, 4, 5, 6, 7. So this is what chlorine is going to look like. So we want these single electrons to bond up. So try to position your lone pairs. Each of the chlorines are going to look like this. Just turn it, okay? So just turn it so that it fits into this picture. It's going to be like a puzzle. All right. So we got our next chlorine. We're going to draw in our other 2 real quick, okay? So you can kind of see that I positioned it so that the single electron is right next to the other single electron. I'm going to do the same thing here. And now what we're going to do is we're going to take those single electrons, we're going to bond them up or connect them, okay? So you're kind of connecting the dots here. All right, and there we go. So let's do our little check. Do we have 8 around this chlorine? Let's see. So we have 1, 2, 3, 4, 5, 6, 7, 8. This one is good. This one, we have 1, 2, 3, 4, 5, 6, 7, 8. This one is good. 1, 2, 3, 4, 5, 6, 7, 8. This one's good. And then phosphorus. 1, 2, 3, 4, 5, 6, 7, 8. And we are all good. And that's our final answer for phosphorus trichloride. All right. So last example that we're going to end with is going to be H2S. And so what we see here is we have hydrogen who only has 1 valence electron. And remember, hydrogen can only go up to 2. So it means it bonds and then it's done. And then sulfur has 6. Never put hydrogen in the center, so we know who's going in the center. We're going to put sulfur on there. We're going to draw our 6 valence electrons on them. 1, 2, 3, 4, 5, 6. And then we're going to position these 2 hydrogens to be next to these single electrons because that's where it's going to bond. So we're going to put a hydrogen right here and a hydrogen right here. Then we're going to connect them to show the covalent bond. And now we're going to do a quick check. Okay, so does this hydrogen have a full set? Yes, because it can only have 2, right? So hydrogen has 1, 2, it's done. So it bonds and then it's done. This hydrogen, 1, 2, bonds and then it's done, right? So these 2 guys are okay. Sulfur needs 8. So we have 1, 2, 3, 4, 5, 6, 7, 8. Sulfur is also done. All right, so go ahead and try your practice and then complete your quiz today.